Dear students, in this video we shall discuss about irrigation system efficiencies. Irrigation system efficiencies implies minimum loss from the time water is taken from the canal outlet till it becomes available in the root zone for plant utilization. The objective of the efficiency concept is to show where improvements can be made so as to have more efficient irrigation. Various concepts of irrigation efficiencies are the irrigation efficiency EI, water conveyance efficiency EC, water application efficiency EA, water use efficiency EU, water storage efficiency ES, water distribution efficiency ED, and consumptive use efficiency ECU. So first one, irrigation efficiency EI. It is defined as the ratio of water output to the water input with the equation EI is equal to WC divided by WR into 100, where EI is equal to irrigation efficiency in percentage. WC is irrigation water consumed by crop during its growth period in an irrigation project. WR is water delivered from canals during the growth periods of crops. In most irrigation projects, the irrigation efficiency ranges between 12% to 34%. Next is water conveyance efficiency. It is water conveyance efficiency EC. It is measure of efficiency of water conveyance system from canal network to water courses and feed channels. Water losses occur in conveyance from the point of diversion till it reaches the farmer's fields, which can be evaluated by water conveyance efficiency. Water conveyance efficiency EC is equal to WF by WR into 100. The next here where EC is equal to water conveyance efficiency in percent. WF is water delivered to the field by conveyance system. WR is equal to water introduced into the conveyance system from the point of diversion. Next is water application efficiency EA. It is measure of efficiency of water application in the field. It is the ratio of volume of water that is stored in the root zone of crops and ultimately consumed by transpiration or evaporation or both to the volume of water actually delivered at the field. It is also termed as farm efficiency. The formula is EA is equal to WS divided by WF into 100, where EA is equal to water application efficiency in percentage, WS is equal to irrigation water stored in the root zone of farm soil, WF is equal to irrigation water delivered to the farm. In general, water application efficiency decreases as the amount of water during each irrigation increases. Water losses due to inefficient application of water in the field vary from 28% to 50%. Next is water use efficiency EU. Having conveyed water to the point of use and having applied it. The next efficiency concept of concern is the efficiency of water use. It is the ratio of water beneficially used to water delivered in the project. With the formula EU is equal to WU divided by WD into 100, where EU is equal to water use efficiency percentage, WU is equal to water beneficially used, WD is water delivered to the field. Next is water storage efficiency. It is defined as the ratio of the water stored in the root depth by irrigation to the water needed in the root depth to bring it into the field capacity. ES is equal to WS divided by W into 100, where ES is water storage efficiency in percentage, WS is water stored in the root zone during the irrigation, WW is water needed in the root zone prior to irrigation, that is field capacity available moisture. The next one is water distribution efficiency ED. It is the expression for distribution efficiency to evaluate the extent to which the water is uniformly distributed. ED is equal to, in the bracket, 1 minus small d divided by the capital D into 100 is equal to 1 minus average deviation divided by average depth applied into 100, where ED is equal to water distribution efficiency in percentage, D is average numerical deviation in depth of water stored from average depth stored during irrigation. Capital D is equal to average depth of water stored along the run during irrigation. The last one is consumptive use efficiencies, ECU. It is defined as the ratio of consumptive water used by the crop of irrigated farm or project and the irrigation water stored in the root zone of the soil on the farm or the project area. ECU is equal to WCU divided by WD into 100. where ECU, consumptive use efficiency percentage, WCU, normal consumptive use of water, WD, net amount of water depleted from root zone soil. Consumptive use efficiency is useful in explaining the difference in crop response from different methods of irrigation. So next is the assessment of irrigation water. The water which has been supplied for irrigation to the farmers is at the government expenses. The beneficiaries in commanded areas derive considerable benefits by way of increased production with insurance against crop failure, use of fertilizers, improved seeds, pesticides, etc. With the availability of irrigation facilities. Next is increased cost of land due to advent of irrigation. It is therefore imperative that the beneficiaries pay for it. The fixation of such charges is termed as assessment of irrigation water. The charges must be levied on the farmers for the following reasons. The reasons are to recover the cost of construction of the project by which it has been possible to supply water. Second point is to recover the maintenance cost of the various works and staff for certain improvement. Next point is to collect some revenue for the nation, and the last is to check the cultivators against uneconomical and careless use of water. So these are the points coming under assessment of irrigation water. Thank you.